Well, hey everybody, Mr. Reeves back with you. And in this video today, we're going to be looking at finding the distance between 2 points on the coordinate plane. All right, hopefully you found the opportunity to watch my previous video where I introduced the two methods we can use, one of which is the Pythagorean Theorem and the other is the distance formula. I'm going to model both ways for you, and then you can use whichever way you like better. Now you'll notice that the instructions say to use the Pythagorean Theorem, but of course you do not have to. All right, so here we go. So we're trying to find this distance right here, and we usually label the distance that we're trying to find d. Now, if you want to use the Pythagorean Theorem, then from one point you go vertically, in this case down, and from the other one horizontally over. But I do want to let you know, if you wanted to go vertically up and then to the right, you could do that as well. All right, and then we find those vertical distances. Now, if the scale is 1, we could just count 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and of course, if that one is 9, then this is also going to be 9. And then this one right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And of course, if that one's 12, then this one's going to be 12. So you can use either the green right triangle or the red right triangle. Sorry, this one's a little skewed here. Okay, either way, if you want to find d, d is going to be the square root of 9 squared plus 12 squared, or if you prefer, 12 squared plus 9 squared, doesn't matter. 81 plus 144, or what's that going to be? 251. Let me check on my handy dandy calculator, which of course I did not open before I started the video. Mr. Reeves, when are you going to learn? All right, here we go. What did we want to do? We wanted to do the square root of 81 plus 144. Whoops, the score. Oh, yeah, sorry. I want to know what 81 plus 144 is first. All right. Oh, my goodness, 81 plus 144. I'm having a hard time today. 225, and the square root of 225 is 15. 15 is that answer that we were looking for. I apologize for that big mess that I made of it. So D is 15. So that's how you can do it using the Pythagorean Theorem. D is equal to 15. We can go ahead and put that in here, 15 units, because it's on the grid. And look at that. Okay, let's do this next one here. Now we want to find this distance going across here. All right, but this time I'm going to go ahead and use the distance formula. All right, the distance formula says that d is the square root of x2 minus x1, that's my horizontal distance, squared, plus y2 minus y1, that's my vertical distance, squared. All right, so right here, I'm going to call this x1, y1. I'm going to call this second point x2, y2. Again, if you watch my previous video, you know that these are interchangeable. This could be your first point, and that could be your second point. It does not matter. But if I do x2 minus x1, I'm going to get negative 4. There's my x2 right there. Minus, and be careful, it's not minus 10. It's minus negative 10 squared, right? Plus, and then what do we have? Y2 is negative 7 minus y1 is 1. And that's going to be squared. Of course, all of this is still in the square root. All right, so negative 4 minus negative 10, well, subtracting a negative is the same as adding a positive. So this one turns out to be 6 squared. This one turns out to be, what, negative 8 squared. So we get the square root of 36 plus 64. Oh, wouldn't you know it, a perfect square of 100. So the answer is 10 square units. Okay, so that one I did using the distance formula. Okay, this one right here, again, I want to find that distance. One option would be go ahead and draw in your right triangle using the Pythagorean theorem. I can draw in that right triangle, or I can draw in, whoops, I didn't quite make it, or I can draw in that right triangle. I can find those distances simply by counting 1, 2, 3, 4, 5 on that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my distance here is going to be the square root of 5 squared plus 12 squared. That's 25 plus 144. That's 169, and the square root of 169 is 13. Or if I had done the distance formula, all right, I could call this right here. Actually, let me do all this in green. I'll call this my x1 and my y1. I'll call this one my x2 and my y2. And my distance would be the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and then if I looked at it, okay, my y1 is 3, my y2 is -9, so -9 minus 3 squared, all right, plus this next one, my y1 is 3, my y2, you know what, I just did the y's, my apologies. Let's start with the x's, shall we? 9 minus 4, how about that? 9 minus 4 squared. My y's were -9 minus 3 squared. All right, well, 9 minus 4 is 5. Hey, look familiar? There's that 5 squared. And this one is actually -12 squared, but guess what? -12 squared and +12 squared is the same. We get the square root of 169, and we get 13. So you see, we get the same result using the Pythagorean theorem as we do using the distance formula, and that's because all the distance formula is it finds these by subtracting. All right, although sometimes you do get that negative, which when squared becomes positive. So you really have a choice which one you're going to use. When you get to the end of this, they do take the grid away, but of course you could get out a piece of graph paper and do it yourself, or plot it on Desmos or something like that. All right, but you can use the Pythagorean theorem, or you can use the distance formula. Both ways are effective ways of finding the distance between 2 points on the coordinate plane. Until next time, have a great day.